Good morning, everyone. In this video, we're going to look at paragraph 7.5 again, in which we will basically wrap up calculating angles. And since this is the last paragraph that we'll cover of chapter 7, this is also the last video for chapter 7. In this video, we're not going to look at anything which is new, so you won't learn anything really new. But we're going to look at an overview of all the tools which should be in your toolbox by now. The first one is looks like this. This is usually what I draw when I think about it, and hopefully you think immediately straight angle. And a straight angle is 180 degrees, and you have to use it pretty often actually. Another one which is somewhat similar to this one is the right angle, but you'll see it a lot less often than the straight angles. Something else which came from another chapter, this one. Maybe you already guessed it, but these are the opposite angles. So if this is, for example, P, and this is 1, 2, 3, and 4, then angle P1 is equal to P3. And you can, of course, also say that P2 and P4 are equal. Okay. Next, we're going to look at the angle sum. So, for example, if we have a random triangle, this is not really a triangle, but now it is, of course. Then we can say that angle A plus angle B plus angle C is 180 degrees. It's called the angle sum. Okay. Other things that you learned this chapter, yes, you also learned about Z angles. So, whenever you see something like this, remember that these two lines have to be parallel. Then there are two Z angles. And the same thing goes for F angles, which you also saw. Remember also two parallel lines, and then these two angles are equal. Okay, then we're going to also look at two special triangles. And those special triangles were the isosceles triangle. And in the isosceles triangle there were two legs which were equal, which also means that there are two angles which are equal. So in this case, angle A would be equal to angle B. Then basically it's older brother, the equilateral triangle, was a triangle in which every side was equal. Then all of the angles were also equal. All of the angles are, let's say D, E, and F. All of these were equal, and all of them were 60 degrees. Remember, 180 divided by 3. So by now, this should basically be your toolbox for calculating angles, and hopefully I'm not forgetting one. I don't think I am. The exercises that you will get in today's homework will also be slightly harder. I wanted to give you one example of a pretty difficult one, so take out your textbook on page, what is it? Page 78. And on page 78 there is exercise 7. I'll make a quick drawing for you over here as well. Like this. And this is D, which is 70 degrees. This is E. There's a line here, 2 point I. No, G. Point F is over here. There's another line down here. 2 point H. These two are equal. This one is 25 degrees. This is F1, F2, G1, G2, 1, 2, 3, and 4. This point is called S. And we want to calculate G2. And we want to calculate S4. And one of the things that usually a lot of you do is they want to calculate these two angles immediately, which is really difficult, and usually it's not possible. So instead of thinking like, what do I have to calculate, you have to ask yourself, what can I actually already calculate? And in this case, this should have been E1 and 2 as well. An easy angle to calculate is angle E1. We don't have to calculate it, maybe we can use it for G2 or S4, but we don't know that yet. So S1 and S2, E1 and E2 are equal. Both of them are at 25 degrees because this line was a bisector. And it might help if you make a sketch and then write your new angles in there as well. Okay. If I see this, then you can calculate angle F12. Why? Because in triangle EFG, all the three angles, sorry, I'm lying actually. In a triangle DEF, all of the three angles together are 180, which means that F12 over here should be 180 minus angle D, which is 70, minus angle E12, which is 50. Which means that angle F12 is 60 degrees. Now we can actually calculate G2 already. Why? Because angle EFG is 180 degrees as well, and we already know angle E2 and F12. So angle G2 is 180 degrees minus 25 minus 60 degrees, which gives you 95 degrees. So right now we do know that this one is 95 degrees, and we know that this entire angle is 60 degrees. Okay, let's see. What I'm also able to do is calculate angle S1. In angle S1, we can look at triangle ESH, and those three angles together should be 180, and we already know two angles, and whenever you know two angles you can calculate the third one. So angle S1 is 180 again, and one thing I noticed right now, I forgot to write down the things that I used. Shouldn't forget these things. Stupid me. Minus 90 degrees, minus 25 degrees. So I'm subtracting these two angles and then I'll get the third one, which is 65 degrees. So this one over here, 65 degrees. And once again, I am actually using the angle sum. Okay, next. Now I'm able to calculate S4. So in triangle S4, we know that angle S14 is a straight angle, so we can calculate S4 by taking 180 degrees minus 65 degrees, which is 115 degrees, because of a straight angle being there. So we're using different things. In this case, we couldn't use the F and Z angles because there were no parallel lines. We also couldn't use the isosceles or equilateral triangles because the lines were not equal, which meant that we had to use the angle sum and the straight angle, and using those two things you could calculate everything. So hopefully you don't give up too easily on these puzzles. Keep in mind that this is one of the hardest parts that we've done so far this year, and if you have any questions, please feel free to ask. Good luck!